Okay, so what's the function notation? So we use a letter. Okay, excuse me. Sorry, someone just joined the meeting. Okay, sorry. So what's the function notations? So we use a letter, normally F or G and H. Okay, so as a name of function. Okay, for example, say F is equal to set of the pairs. Okay. By the way, so what is a function? Okay, somebody asks you to function about function definition. You may just see right there. So the function between two variable x and y means that y is a function of x. Okay, you can say that. Okay, so it means that y is determined by x. So a variable is determined by the another variable x. Okay, and then but that's not the precise definition of function. So I told you the last time we saw that the definition of function is this: a function is set ordered pairs in which no two ordered pairs have the same first coordinate but different second coordinate. So why this is important? Because if problems the give you the set ordered pairs and then ask you to determine whether or not the set is function, then you have to directly you have to use that definitions. Okay, so try to find out two of the pairs have the same but different second. Okay, then that's not what the function. Keep in mind this, that's not a function. So then what if problems give you the graph? Okay, I want to figure out this graph is graph of function, then we're going to use a vertical line test. Okay, so vertical line, just draw the vertical line. Okay, and then the vertical line meet the graph more than once, then that's not a graph of function. So the one of the popular example of what circle, you know, for any circle meet the what the vertical line more than once. So the circle is not a graph of function. Keep in mind this. And then we learn the domain range, right? So domain is set of all the pair first coordinate. The range is set of all the second coordinates. Okay, so keep in mind this. Now the function we use the letter f, and then see the f of 2. Then once we define f as set of order pair 2, 5 is 3, 8, then f of 2 that doesn't mean f times 2. Okay, so f of 2 means the y value. Okay, or second coordinate corresponding to x value 2. Okay, so keep in mind this. And then now the we can use g of x or f of x or h of x. Okay, so any letter we can use to represent function. Okay, um, now the c give me a second. Give me a second. So let's see example, by the way. So in the textbook, give me a second. So let's see. All right. So yeah. So the last time I couldn't finish example 7, right? So now let's figure out the D and E. Okay, E. right here. Okay. Let's say D and E. Okay. So what's the g over x minus 2? So you see that two functions are given. Okay, here the function is given as equation, right? So f of x equals 2x squared minus 2, and the g of x equals 2x minus 3. So and then the question is to find and simplify each of the following expressions. So that's a really good example to check whether or not you understand function notation. Okay, so see stuff. All right. Example 7. All right. So f of x is defined by x squared minus 2, and the g of x is defined by 2x minus 3. Okay, so now, so keep in mind this, the x inside the parenthesis of function notation represent first coordinate. Okay, if x is what the something inside the parenthesis, I mean the x will be changed to a new symbol or variable or algebra expression, you gotta replace every single x on the right hand side equation by that algebraic expression. Okay, keep in mind this. So now then what are you gonna do? All right. So what that means? So let's see D. Okay, let me explain what that means by solving the problem D. G of x minus 2. Okay, so it means that, see, x minus, that doesn't mean that subtract 2 from x. Okay, it means that x minus 2, the whole thing is now uh, what the new the x coordinate, first coordinate. Okay, so you gotta just replace the x, okay, in the what in the function of g by x minus 2. Okay, do not say that 2 times x minus 2 minus 3. Okay, it is. Second. Second. Okay. So that's just completely wrong. Okay. So we'll just replace the x by x minus 2. Okay. So the right answer is 2 times x minus 2 and the minus 3. Okay. So I'm simplifying this. We're going to get what 2x minus 4 minus 3, which is 2x minus 7, right? Okay. So and then e, g of x plus h. Okay. So minus g of x. So actually, this is the numerator of the difference quotient. Okay, but we're gonna see that later. So let's find out the g of x plus h. Okay, we already know g of x. This is given problem, right? 2x minus 3. Okay, so we'll figure out the g of x plus h. Okay, so now then, I told you that doesn't mean that just add h into x right here. No, we don't add h into x. We replace, okay, x by x plus h. So we're going to get 2 times x plus h minus 3. Okay, so this is going to be 2x. I know this. What is h? You may just confuse. What is the wait, what is h? What is x? Yeah. So now x plus h whole thing is just x plus h. That this represent the first coordinate itself. Okay, so so 2x plus 2h and then minus 3. Okay, so excuse me. Now we subtract what g of x, okay, from 2x plus 2h minus 3. So this is equal to, So 2x plus 2h minus 3, right? And the minus g of x, which is 2x minus 3, right? Okay. So where that comes from, 2x minus 3, that's the what? Definition of function g of x. Okay. So we'll just plug in 2x minus 3 into g of x, okay? Okay. In my experience, just students confused how we got this from g of x. Because to calculate functions, you have to apply, substitute the equation of function into the, or sometimes this is called the equation or definition or rule. Again, that depends on textbook. Okay, but let's say the equation of this one into the drawbacks. Okay, so now this is equal to 2x plus 2h minus 3 minus 2x and then plus 3, right? So minus 2x plus 2x plus 3 minus 3 is gone, right? So we got 2h. So this is the answer. Okay. So now we move to the difference quotient. Okay. Let's see. So what's difference quotient? The to understand difference quotient, we gotta look at the average rate of change. So see that average rate of change, but this is nothing but a slope. We see that y2 minus y1 over x2 minus x1. We haven't seen this one in chapter 1 when we go over the linear equation, right? So in a slope in a set form, the m, that's a slope, right? So slope is change in y or change in x. So if 2 points are given, okay, then change y or change in x. Give me a second. Somebody just joined the meeting. Okay, so now the change y change, if 2 points are given, then we can figure out the change y or change in x, which is y2 minus y1 over x2 minus x1, right? So, but yeah, so the let's see. Okay, I mean, what's delta y? You don't have to take a look at this delta y and delta x. Okay, but just delta y, normally we use delta y, delta to represent the difference or change in mathematics. Okay, so you may see that symbol in online homework, but um, just that means just a change y. Okay, delta x means change in x. So see example. You see, okay. See example. This is example 8 in the textbook. Okay, so the population of California was 29.8 million in 1990 and 33.9 million in 2000, the US Census Bureau. So what was the average rate of change of the population over that time interval? So now, let's see, I'm gonna explain then what's the, why do you, what's the, can I say that? Just kind of difference between every rate change and just the slope when we study in chapter 1, okay, by solving that example 8, okay. So first, what we're going to do, we need to construct the two ordered pairs, okay? So to construct ordered pairs, what? Because we need to define the x coordinate and y coordinate. Because ordered pair consists of what? First coordinate, a second coordinate. X coordinate, y coordinate, right? So now I set first coordinate year, okay? 1990, 1991, okay, 2000, 2010. So in the y coordinate, I set to the population of California, the y coordinate, okay, or we can say second coordinate, okay. So sit back to sketch papers. So let me do the next one. Okay, so right here, example 8, right? So let's say this is the year, x coordinate, okay, represent year. Let's say the vertical line on the y-axis represent population. Okay, the unit is a million, okay, and the unit of year, the time is year, okay. So maybe 1990 right there, and the 2000 is right there, and then 29.8, yeah, 29.8 million right here. So we got 1 point right there. Okay, so ordered pair is what? 1990, comma 29.8 million, right? And the other one is what? when 2000, what the population of CA is 33.9, right? 33.9. So we got the point. It's the order pair. So 2000 and then 33.9. You see? All right. So we got two order pairs. Now we're ready to calculate the average rate of change. Okay. So the average rate of change. But actually, what does that mean? Average rate of change in this problem. So average rate of change of what? Population, right? So the rate of change of population from 1990 and 2000 is what? That is equal to y2 minus y1, which is here. What's the y2? Yeah, so this is x1, this is y1, this is x2, this is y2. Then y2 minus y1 going to be 33.9 minus 29.8. Okay, divided by 2000 minus 1990. Okay, so we calculate this one. You're going to get, I think, a 0.41. Okay, right. So now, what does that mean? So actually we don't know exact graph of the population of California per versus the year, but maybe the graph is maybe like this, like that. I don't know exactly, but definitely the graph of the population California versus year must pass through 2 points, right? That makes sense. Okay, but so this average rate of change just represent it's literally just average the slope between 1990 and 2000. Okay, it's kind of, so what we got is actually we drew the just the line, straight line passing through 2 points. Okay, so now, and then we just got slope of this one. Okay, so which is a change in y or change in x, but that doesn't point to 41, that doesn't represent what the actual rate. Okay, actual rate at any point. Okay, but just average rate from 99 to 2000. Okay, so but I want to generalize this. Okay, so to generalize this, the average rate of change. So let's see. Okay, yeah, so x is y, x is okay. So the right here, so y2 minus y1 over x2 minus x1 right here. So I want to generalize this average rate change. I want to express the what x2 in terms of x1. Okay, so what I mean is this: I'm gonna use just letter x for x1. Okay, and then I'll just express x2 as x plus h minus. Okay, what is h? So let's say here is x1 right here, but I told you I'm going to use letter x instead of x sub 1. Okay, that represents x sub 1. Okay, and then h represents distance between x1 and x2. So right here is x2. Okay, and then distance between x1 and x2, let's say h. Okay, then that's going to be x plus h. x2 can be expressed as x plus h, right? Now, and the actually y1 is what? Y1 is the y value corresponding to x1, and the y2 is y value corresponding to x2, right? So let's say we assume that we know the function of the population, okay, so that we can figure out the population at any year, okay. Then let's say the name of the function of population is f. Then we can say y1 is nothing but what? So y1 is nothing but f of x1, right? But we change the name of x1 to x. So this is just f of x, right? And the y2 is what? That's going to be nothing but what? f of x plus h, right? Okay, so the f of x, that's the y value corresponding to x. Okay, in this example, the 29.8, that's the f of x1. Okay, 33.9, that's the f of x2. Okay, if the the equation of this graph is f of x. Okay, so now the what the y value corresponding to x plus h, that's f of x plus h, right? Okay, so now the average rate of change is what? Change in y or change in x, which is what? F of x plus h minus f of x divided by x plus h minus x, which is what? X, right? This is x plus h minus x is h, so bottom one h. So that's the difference quotient. So what's the difference quotient? Just a general form of the average rate of change. Okay, the implying the function notation. Okay, so now see example. There's a difference quotient. Let me write it down. Okay, quotient. So let's see example in textbook. This. Yeah, example 9. Let's see two problems, B and D. Okay. Other two problems, A and C. Yeah, just look at solutions. It's just really perfect. Okay. So example 9. All right, example 9. Yeah, so B. Okay. So 2 f of x, that is equal to x squared minus 2x. Okay. So what I'm going to do, we need to find out f of x, step 1. Okay, step 1. We need to find the f of x plus h. Okay. So still you just confused. What's h? So too many letters, symbols right there. Yeah, then you may just say that h is nothing but just some number. Okay, small number, maybe 0.1, 0.2. Okay. So then f of x plus h is gonna be x plus h squared minus 2 times x plus h. I told you that doesn't mean that what adding h into x. No. Now x plus h is the new x coordinate. Okay, x plus h is the represent, you know, the x coordinate. Okay, not just x alone anymore. So we completely replace every single x on the right hand side of the function f by x plus h. So that is equal to the x squared and the plus 2xh, right? And then plus h squared and the minus 2x minus 2h. I don't think, yeah, you may simplify this, but let me leave it because eventually we're gonna say step 2, we're gonna simplify f of x plus h minus f of x, right? So what are you gonna do? Yeah, so we simply do algebra, okay? So just copy this down, okay? That's the f of x plus h, right? X squared plus 2xh plus h squared minus 2x minus 2h. Okay, the minus f of x is what? X squared minus 2x, right? So you see that we're gonna get the negative x squared, positive x squared, cancel them out. The minus 2x, which is positive 2x. There is a negative 2x. Cancel them out. Okay. So we got 2xh plus h squared minus 2x, 2h, right? So which is a 2xh plus h squared and the minus 2h. Okay. So that's the numerator. And step 3, now we divide this one by h, right? By following the difference quotient formula, okay? So f of x plus h minus f of x divided by h, that's gonna be 2xh plus h squared minus 2h divided by h, right? Okay, but see that the all of terms in top and bottom have what common factor h, right? So let me what cancel them out, the h common factor h. Okay, so now this is equal to, you see that this guy has h, this guy has h, this guy h. So let me factor out h in top one. So we got h times 2x plus h minus 2 divided by h. So cancel them out. So we got what 2x plus h minus 2. Okay, that's the answer. I mean, that's difference quotient. Okay, so now d, so b is always a b. Okay, so b. Let's see. Okay, so if you missed something here, then just watch the lecture video. Okay. So now d, y is equal to 5 over x. Yeah, so y equals 5 over x. It means that y is determined by x, right? So actually y is a function of x. So let me use function notation instead of y. So let's say g of x, okay, is equal to 5 over x, okay? So these two expressions are identical, okay? Right? So somebody asks you that what is g of x? You may say that y, letter y, okay, variable y, okay? So step one, you find out g of x plus h, okay, which is the what? 5 over x plus h, right? And then step two, we find out g of x plus h minus g of x. Maybe that's going to be tedious, but listen carefully. So g of x plus h is 5 over x plus h, and then minus g of x is 5 over x. I think we have to do combine two fractions. But look at this. Two fractions have distinct denominator. So we got to find the LCD, least common denominator, which is x times x plus h. So this is equal to the x times x plus h. Okay, that's LCD, right? So to get the x times x plus h in a first fraction, we multiply by what? X, right? And top and bottom. Otherwise, the ratio gonna be broken. So now we got 5x top one, right? And for second fraction, to get the x times x plus h, we need to multiply by x plus h and top and bottom. So see the top one, 5 times x plus h. Okay. So see the 5x, negative 5x, it's gone. So we got negative h and then x times x plus h, okay? Now that's the numerator. And then we still have one more step, okay? So let's see, step 3, okay? So we do minus h over x times x plus h divided by what? H, right? Okay. Then this is nothing but what? Minus h over x times x plus h times 1 over h, is it? Okay, you got it? Because I just pulled down numerator, okay? Let's see example. 5 over 3 over 2, what's that? This is a 5 over 3 times 1 half, isn't it? Okay, so we got 5 over 6, right? So now then this is equal to what? H cancel them out, right? Because you know cross the factorization. So we got minus 1 over x times x plus h. Okay, so that's the difference quotient. So I solved the B and D, okay, but please look at the A and C by itself, right? So now we move to, we'll see online homework problems, okay? So now, oops, where's my, move to, let's see, give me a second. Here, so what problem do we solve? Mm, 17. Oh yeah, let's see. Okay, so problem number 17. Find the difference quotient for the following function and simplify it by rationalizing the numerator. Um, but let's see that j of x is equal to square root x plus 10. So let me find out domain and range first, okay? Because I think probably, okay, you will see the, the a problem asking you to find the domain range of root functions, square root functions, right? Okay, so I solved the similar problems, but let's see. Okay, I'm gonna find a domain range. I know this problem doesn't ask you to find domain range, but let's find out that. So let's see. Yeah. So now here the j of x is defined by the square root of x plus 10, right? Okay. So now how can I find the domain range of the square root function? So for the domain, okay, the domain we solve the inequality x plus 10 is greater than or equal to 0. Okay, why? Because the quantity under the square root must be greater than or equal to 0 to get a real number. Otherwise, we're gonna get the complex number as the y value. Okay, so in chapter 2, the x variable, y variable, I mean domain range must be on the set of real number. Okay, so we don't deal with the domain and range which is beyond the set of real number. Okay, so x plus 10 must be greater than or equal to 0. Keep in mind this. Whenever you get the function involving square root, then the quantity under the square root, or you can say algebraic expression under the square root, must be greater than or equal to 0. From that fact, okay, so you can find out the domain. So it's not a big deal, right? So this is x is what? Greater than or equals negative 10, right? So yeah, so is negative 10 close to infinity, right? So domain must be what? Negative 10 to infinity. Okay. What about the range? Range, the square root term is always greater than or equals 0. For any choice of x, okay, on that domain, square root of x plus 10 must be greater than or equals 0. Okay. Or simply just think about this. Can you find out a number that makes square root is negative? Okay. Think of this. Even though you put the square root a negative number, for example, negative 2, that's not a negative number. This is complex number. Okay, keep in mind this. Complex number doesn't have um the order of number. Which one is bigger than the other one? Which one is lower than the other one? No, there is no such a concept. Okay, complex number is just complex number itself. So now the range is simply what? Second one. Range is simply 0 to infinity. Okay, x square root of x plus 10 can be 0 when x is negative 10, right? Okay, so keep in mind this. And now back to the problems. Find the difference quotient. Okay, so let's see. Now j of x plus h. Okay, j of x plus h. Okay, minus j of x, right? Okay, so step 1, we find out j of x plus h minus j of x. Now, see, that is equal to, so this is equal to, now, what's j of x plus h? That's going to be square root of x plus h minus plus 10, right? Okay, that's the j of x plus h. And the minus j of x is square root of x plus 10, right? So this is j of x. Okay, and then, yeah, can you simplify it? I don't think so. I'll just leave it. Okay, now step 2. yeah, we divide this, the numerator by h, right? So we got j square root of x plus h plus 10 minus square root of x plus 10 divided by h. Okay, so that is equal to, okay, this is equal to, now the problem says what? Rationalize. What does that mean, rationalize? Rationalize means that they get just a number, I mean algebraic expression without square root symbol in the top. Okay, that's called the rationalize. Okay, so to rationalize, we need to multiply the conjugate of this. What does that mean, conjugate? So the square root of a plus square root of b, the square root of a minus square root of b. Okay, so let me multiply them. Okay, I'm going to multiply square root of a plus square root of b by square root of a minus square root of b. Okay, so here's key. Same quantity as square root of a right there. Same quantity of second term right there. The only different thing is the sign. Plus, minus. Okay, multiply. Okay, then what happened? We're gonna get, let me do FOIL. You can check that. When you do FOIL, you're gonna get this: square root of a square minus square root of b square, which means that a minus b. Okay, so now the square root term is gone. You see, square root is gone, right? So this is the way to rationalize some algebraic expression involving square root term. Now square root a minus square root b, this is called conjugate of this. Okay, or this is called the conjugate of this. So each one is conjugate. I mean, this one is conjugate each other. Okay, so now the let's get, sorry. So now the what? Let's find a conjugate of this. I mean, I'm gonna multiply by the conjugate of this numerator. Okay, so that means what? Let's see, the square root of x plus h plus 10 minus square root of x plus 10. That's just a numerator. Multiply by what? Conjugate of this guy is what? Square root conjugate. Okay, conjugate. So square root of x plus h, okay, plus 10 plus square root of x plus 10. And then, so when you divide by something in numerator, you have to do the same thing in denominator, right? Otherwise, the ratio is going to be broken. So now h times square root of x plus h plus 10, okay, plus square root of x plus 10, right? Okay, so now the, let's see, x plus 10, x plus h, yeah, this is equal to, then we got this, x plus h plus 10. Okay, I just copy this one, minus x plus 10, don't forget to put parenthesis, okay, divided by h times square root of x plus h plus 10 plus square root x plus 10. Okay, so that is equal to, you see that negative x, negative 10, that will be cancelled out with a positive x, positive 10. Okay, so h gonna be left at the top. And then, but actually, you see that? There is h in the bottom. So they're gonna be cancelled them out because h is a common factor of top and bottom. So we got 1 over, okay, the square root of x plus h plus 10 plus square root of x plus 10. Okay, so now, what are you gonna do? Now, next problem, let's see. Excuse me. Yeah. So 17. Yeah. Mm, yeah. See, determine the domain range of the relation. So actually, that relation between y and x function, because y determined by x, Okay, and then the graph of this function pass the vertical line test. So anyway, domain must be what? Closing number 4 to infinity. Otherwise, x minus 4 going to be negative number. So to be that x minus 4 is greater than or equals 0, x must be greater than or equals 4. So closing number 4 to infinity, that's going to be answer. Okay. So now, let's see. All right, so determine whether the relation is a function. Okay, so here, letter T is a function name, okay, of the set. Okay, but we don't know still if the T is just a set of, I mean, the function that's a set of ordered pair is a function or just relation. What you're gonna do? We try to find that two ordered pair have the same first, different, second. Okay, if they are, then what? The set is not a function. Okay, so what it means that what we directly apply the definition function. Okay, so but I think you see that 10,9 and the 10,4. So two ordered pairs have the same first but different second. So the answer is no. That relation is not a function. Okay. Then use the vertical line test on the graph given to the right to determine whether y is a function of x. Is y a function of x? The answer is yes. This is a function of y because we just draw the vertical line. Okay. Then what? The vertical line just pass the across the line function graph of function just one time, right? Only once. So now next one. Yeah, I think it's done. So see. Now new leader ASD. All right. So okay. So let's move to 2.2. Okay. So. So 2.2. So let's see textbook. Okay. I'm gonna cover 2.2 by looking at the textbook. 2.2. Yeah, 2.2, we're gonna just see around the 10 different type of graph, okay, of functions. So 2.2. The first one is a square function. So yeah, I'm gonna introduce a square function and then graph of square function and then domain range of it. Okay. So what's a square function? You can see that y is equal to x squared. That's the is called the square function. And the graph of the square function is this. You see that figure 2.10 right there. All right. Okay. So now, give me a second. So right here. But let me compare the square function and then cubic function. What that means? Here. Okay. So y is equal to x squared. That's square function, right? Okay. And then y is equal to x cubed. That's a cubic function. Okay. And then let me figure out the graph of the power function. I mean y to the x to the nth power. Okay, here n is odd, even. I'm sorry, n is even. It means that n is just could be 2, 4, 6, 8, 10. Okay, so this is even order power function. But this says power function. Okay, so and then here y to the x to the nth, and the n is even. Sorry, odd. Okay, this is also a power function. But well, in this is a power function, but n is not even but odd. So 3, 5, 7, okay, 9. All right, so the graph of the square function, we saw that, right? So it should be like this. Okay, this is graph of the square function. So when x is 2, let's figure out the ordered pair. I mean, pair of some points. Okay, when x is 2 and 4. When x is 2, then what? 4. Yeah, I know this doesn't look like 4, but okay, please understand that. So 4, right? Because 2 squared is 4. Okay. So how can you find y value corresponding to x value? If if the function, I mean, equation of function is given, we'll plug in 2 into x. Okay. All right. So now then, now we know how to we know the what the how to express this one in terms of function notation, which is what f of x is equal to x squared. We can say that. Told you, right? So y equals x squared, f of x equals x squared. It's identical. Okay. So now when x is 4, then what? We're gonna get 4 squared, which is 16. 16 right there. Okay. Excuse me. Now let's then figure out the graph of the power function when n is an even number. Okay. So that the graph of the power function when n is even is similar to the graph of the square function, but see, I mean, think about this. When x is 2, I mean, think about this. The g of x is equal to x to the fourth power. Okay, this is one of the example of power function. N is 4, even number, right? Then when x is 2, the 2 to the fourth power is what? 16, right? So there is 16 right here. Okay. And then when x is 4, 4 to the fourth power is this huge number, right? So I cannot, you know, draw the point at x is 4. It's okay. So but then we can see that what graph must be like this. Okay. So as you can see that the power, okay, so exponent is increase, then the width of this, I mean this type that kind of graph is called parabola. Okay. Okay. Parabola. All right. So this kind of the type of graph is called parabola. Okay. So the width of parabola is getting narrow as exponent is increased. So you see that. So now what if x is to the sixth power? Then we're gonna get more the narrow the width of parabola. Okay, than this. So now let's figure out the then graph of QB function. Okay. So graph of QB function is like this. How come? So the just think about this. Here the reason that we got the graph like this in the when x is a negative number because square. Because negative square is what? Positive, right? Because negative times negative, positive, right? So here, what about this? When x is negative 1, the negative 1 times negative 1 times negative 1, that's going to be what? Negative 1. Okay? So negative, just multiply negative other times, what? We still get negative sign, right? Okay, that's why graph is like this. This is a negative 8. Okay, see that? All right. So now then, the power function when it is odd must be graph is, okay, see, this, and then like this. And then still similar to this, but yeah, the width of this is not the parabola. Okay, this kind of graph is not called the parabola. Keep in mind this. Then, but as n is increased, okay, 6, 5, and 7, and what 9, n is increased with odd numbers, then the width gonna be narrow. Okay, keep in mind this. Okay, narrow. So maybe let's say this is y is equal to x to the fifth power, and then let's say this is y equals x to the seventh power, something like this. Okay. So now keep in mind this. Okay. So in 2.2, yeah, we'll see yeah, around the 10 different type of functions. Okay, their graphs. So please memorize those graphs. Okay, so that's going to be useful. And then we need to, yeah, we're going to use that, you know, the graph in 2.3. Okay, so keep in mind this. So now, by the way, let's figure out the domain range. Okay, so here domain going to be what? Let's see, domain. So how can you find a domain from the graph? Since domain is what? Domain is set of first coordinate. Okay, so the domain must be belong to what? The x axis. Okay, and then look at this. Which graph goes up infinitely, right? So for any choice of x value, there exists y value and corresponding y value. Okay, so the domain gonna be what? The negative infinity infinity. Okay, so negative infinity infinity. That's gonna be domain. Domain is negative infinity infinity. But what about range? Range is look at this. For any choice of x value, taking square, you're gonna take a square, right? So when you take a square, then what? We're gonna get always positive number, right? So y value cannot be a negative number, and then we can see that what from the graph. Graph is lies on the what? Above the x-axis, not below the x-axis, right? So graph never across the x-axis below. So it means that what? Y range is gonna be 0 to infinity. Okay, you see here 0 to infinity. Okay, so range is gonna be closing number 0 to infinity. Okay, so same goes here. Okay, when n is even number, okay, in a power function, domain is just negative infinity infinity. Okay, and the range is a 0 to infinity. Okay, so now let's see domain is what was this? Negative infinity infinity, right? Because you see, x can be any real number. There is no restriction. So it's negative infinity infinity. And the range is going to be what? Negative infinity to infinity 2. Because see that y value can be negative number. Because when x is negative, because negative number to the cubic powers to what? We're gonna get negative number. So range gonna be negative number. I mean, y value can be negative number, and then we can see that graph is across x-axis, below down. So y value can be negative number. So range gonna be negative infinity infinity. Okay. So here, same thing here. So domain is what? Negative infinity infinity, and the range is equal to negative infinity to infinity. Okay. So Now let me stop here. Okay. So now, yeah, because let's see.